Good morning or afternoon. I am one student. This is Mrs. Kaufman, and we're going to go over the similar polygons lesson. So today we're going to learn the difference between a similar figure and actually a congruent figure. Now, we've been talking about congruent figures, and we know the corresponding angles are equal and the side lengths are equal. So this angle would be congruent to this angle congruent to this angle, and so on. And then the side lengths would also be equal. But when we talk about similar triangles, we are talking about triangles that have still corresponding angles that are equal. So this is equal to this, and this is equal to these three, so that as they correspond, but the side lengths are proportional. And we're going to talk about what that proportional means as we go through the lesson. So those are the two differences between similar and congruent figures. So the first thing we're going to do is define a polygon. And a polygon, if you took a moment and Google it, would tell you it is a shape with at least 3 sides. And the shape has to be a closed shape, meaning that a triangle is a polygon, but if I drew something like this is not a polygon. Nope, has to be closed. And then again, when we were talking about a polygon, any polygon, we know that if they're similar, that the angles are equal and the side lengths are proportional. And just a reminder, if you feel I am going too quickly in this video, please feel free to pause the video at any time. All right, let's move on. So now we've got these polygons, and these are different types of polygons. We've got a couple of triangles here, and we have a trapezoid there. And what we want to do is read the instructions and then follow along with what they want us to do. So I'm actually going to make this go down a little bit more. Actually, I'm going to make the view come out a little bit. All right, so given the similar figures, name all the pairs of corresponding sides and angles, and look at the similarity statement to help. So what I also had you guys do is look at the similarity statement. I'm sorry, I'm stumbling. I apologize. Look at the similarity statement, and we see that PQR, and this symbol right here means similar rather than congruent to triangle DEF. So when I look at the side here, side PQ, it's similar, QP, excuse me, yeah, QP, it's similar to ED, and I'm actually going to write it that way. So it's going to be similar to ED. And then I'm going to write a line over it. The next one I'm going to look at is PR. So from here to here, PR is similar to DF. So I'm going to write DF right here and put a line over it because the sides are similar. They are not equal, and we can visually see that they are definitely not equal. And then RQ. RQ is similar to EF. If you're doing this on your own, you could be using patty paper to line up tracing this out, marking the vertices and kind of lining up the vertices to know which one goes where. So now let's look at the angles, and I'll use a different color for the angles. We see that angle Q lines up with or corresponds to angle E. And notice too that they are, according to our definition, our Q is going to be congruent to E. So if this was 50 degrees, E is also going to be 50 degrees. Then we have angle P is congruent to angle D. I'm going to write this here. And then angle R is congruent to angle F. That means they're all going to be the same angle measure. Okay. So now we can do it for this group as well. So for number 3, let's do the same thing. I've got LM is congruent to, well, wow, we got to really think about this one. Looks like LM corresponds with SR. If I was to turn this triangle this way or rotate it, it would rotate and correspond to side SR. So I'm going to write that down here. And then we have MN is corresponding to ST. Hope you guys are seeing that. And lastly, NL is corresponding to TR. All right. So now we have our corresponding sides. Now let's do our angles. Angle L is corresponding to angle R in the other triangle. Angle M is corresponding to angle S. And they are equal, or they are congruent. And angle N, 1, 2, 3, is congruent to angle T. Now, if we go down here, use the similar polygons to write statements about their proportionality. So we know if we say that they're similar, our side lengths have to be proportional. So what does that mean? So let's match these up. LM has a side length of 9. So I'm going to write 9 down here. But SR has a side length of 6. I'm going to put that underneath here. All right, let's look at the next one. MN has a side length of 12, and it corresponds to ST according to this, which is side length of 8. And then lastly, NL has a side length of 15, and that corresponds to RT, which has a side length of 10. All right, so now that we have that down, notice those numbers all look different, right? But if I put those in my calculator and I just did 9 divided by 6, that's what that means. I hope you all agree with me on that one. So if we do 9 divided by 6, we should get 1.5. I'll write it above here. Now, if these are similar triangles, all of these should equal 1.5. So let's double check. What's 12 divided by 8? That's also 1.5. And then what's 15 divided by 10? Well, guess what? It is 1.5. So these are similar triangles. So now I want you to do that on your own for this one, number 4. Remember, you're going to write the relationship down. What side corresponds with what? This AB is going to correspond to EF. And that's going to be side length 6 over side length 9. And you guys finish the rest. All right. Now what this 1.5 means is that is the scale factor. This 1.5 is called the scale factor. And that scale factor tells us how much bigger triangle LMN is to RST. So you're going to figure out how much bigger HGFE is to ABCD by using those proportions. So the last couple of pages, just to give you a little hint here, you are still finding the scale factor using the corresponding sides. Use that patty paper if needed. And then you're going to have a couple more challenging problems where we're going to need to find the side lengths using the Pythagorean theorem, a squared plus b squared equals c squared. Remember, this is A, B, C, A, B, C. And then you're going to use the area model, or area, to find the area of a triangle. It's going to be the area is equal to 1/2 the base times the height. Remember, this is also your base. That kind of works out. B is your base. The 20 right here is also your height. All right. Good luck, and I will see you in the next video.